In this video, we'll be going over remove duplicates from sorted array. So given a sorted array nums, remove the duplicates in place such that each element appears only once and returns a new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. So in our first example, we have 1, 1, 2. So we want to remove the duplicates and shift the unique elements over to the left. So we get 1 and 2. Now the length of the new array is 2, so we output 2. So in our second example, we have 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. So when we remove the duplicates, we get 0, 1, 2, 3, 4, 5, which has a length of 5, so we return 5. We basically did this the same thing. We want to remove we want to shift the unique elements to the left and remove all of the duplicates. Or we can just say we want to replace all of the duplicates with unique elements. Now let's go over the thought process. We can implement a two-pointer approach. So one pointer I will be on the left side to populate unique elements. And then one pointer J will scan forward to the right to find unique elements. And since the input array is sorted in ascending order, all of the duplicate elements must be grouped together. So if we find a unique element x at index j, we can populate x at pointer I before moving I forward. Then we can skip all of the occurrences of x. To find our next unique element. Then after j is out of bound, the second pointer that we're scanning forward is out of bound. That means we have processed all of the elements. Then the value of I will determine the length of the new array, of the resulting array. Now let's go over a pseudocode. So we're going to create a variable I to be a left pointer. Left pointer to populate unique elements. Then we're going to iterate through the indices of the input array. So we're going to denote it as j. Then we're going to populate the current unique elements at pointer I. So we're going to set nums I to nums j. Then we're going to move our pointer I forward. So we're going to increment I. Now we want to skip over the duplicate occurrences while j is not at the last index. And the next element is equal to the current elements. Then we want to skip the elements, so we're going to increment j. Then we're going to, after we process all of the elements, we're going to return I, which would be the length of the new array. Now let's go over the time and space complexity. So the time complexity is equal to O of n, where n is the length of the input array. We visit each element once with pointer j, and our space complexity is equal to O of 1. Now let's go over the code. So we have create a variable for our left pointer, and then we're going to iterate through. Populate the current unique elements at I before incrementing it, so it's post increment. Then we're going to skip over the duplicates while j is not the last index. And the next element is equal to the current elements. Then we're going to increment j. This loop will allow us to reach the last elements of the duplicate elements. Basically the last duplicate elements. And then after we reach the last duplicate elements, this loop will allow us to get to the next unique elements. Then we can return I, the length of the resulting array. Let me know if you have any questions in the comment section below. Like and subscribe if you would like more content that will help you pass the technical interview. I upload videos every day, and if there are any topics or questions you want me to cover, let me know in the comment section below.